Hello, and welcome to another episode of Casual Learning. I'm your host, John Bannan. What's the deal with infinite subdivision? Infinite subdivision is an idea that you can continue to divide things into smaller and smaller and smaller quantities forever, for infinity, ad infinitum. There is no smallest unit of matter or reality. So, infinite subdivision would be, you take a thing and you cut it in half, right? And then you take that half and you cut it in half again. And then you take that quarter and you cut it in half again. And the idea of infinite subdivision is you can continue to do that, keep cutting the thing in half. And you can do that infinitely. There's no end to it. Up until just a few days ago, there was no scientific study that had specifically addressed this question of whether infinite subdivision is possible. The problem with infinite subdivision is the smaller you get, you eventually reach a point where you can't study anything because it's so small that scientific instruments can't tell you anything about it because it's too small. So this is really a very mysterious um, area of study, of scientific study. But just recently, there was a study that actually said something about this. Now, uh, in in physics, there is a scale called the Planck scale, which is basically the smallest anything could ever get and still be a measurable thing that science could say something about. And the Planck scale is the size of 10 to the negative 35 meters. It's actually 1.6 times 10 to the negative 35 meters. So that's what a Planck length is. That's how small the smallest subdivision that science can even say anything about is. That's how big it is. So it's 1.6 times 10 to the negative 35 meters. That's very, very, very small. Uh, so the question is, well, is there anything smaller than that? Can you subdivide from that? And the answer until very recently was no one knows. We don't know of anything that is as small as a Planck length, let alone anything smaller than that. So, a very common argument among uh, atheists is that you can engage in infinite subdivision. Um, Now, there was just a study done, and it came out of Cornell University. And the study was dated January 16, 2020. And the study is called um, A Limit on Planck Scale Froth with espresso. Now, they're not referring to a shot of espresso coffee. They're referring to a specific scientific instrument called the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, espresso, which is located at the European Southern Observatory's Very Large Telescope. Now, what these physicists did is they figured out a way to find out what is going on at these extremely tiny units of reality, the Planck scale. And the way they did that is there are theories of quantum gravity that talk about how there should be a frothiness or this of a virtual sea of minute particles popping in and out of existence constantly at these smallest scales, this Planck scale. And this frothy sea or foam, this quantum foam of particles popping in and out of existence, if it was there, these physicists figured out that it should have a certain effect on a light beam that happens to travel billions and billions of light years. So essentially, these physicists were trying to determine whether space-time at these very small scales, this Planck scale, is smooth or is it chunky? Does it have this frothiness or not? And what they did was they know that a light source would gradually disperse in energy due to space-time fluctuations over large distances. So if this frothiness at this lower level would have an effect on the energy of the light beam traveling through it, sort of like a gravel path. If something is running over a gravel path, there'll be lots of bumps as it goes across. Some of those bumps will give it more energy, make it go up, and some of them will make it go down, dip in energy. But there will be basically this vibration as it goes through this gravel path or over this quantum foam that should have the effect of dispersing the energy of the light over a long enough distance. Now, because this quantum foam or this gravel path is so tiny, it's at such a small scale, an unbelievably small scale, that the effect it has on the light beam is not pronounced at all. And in order to get a pronounced effect on this light beam that you could actually measure with something like espresso at a very large telescope, the light would have to travel an unbelievable distance through this quantum foam in order for you to even tell that there was a difference. And these physicists got the great idea, okay, well, let's look at a light source that's billions and billions of light years away. So this light from this distant light source has traveled through, in this case, 18 billion light years of universe. And that's such an enormous distance, even when the effects of quantum foam are so minuscule. If a light beam travels that sort of distance, the effect of even this minuscule quantum foam should show up as a disbursement of the energy of the light source. So that's what they figured out, and they measured to see whether there was a disbursement of energy in light coming from a source that had traveled 18 billion light years from the star, the light source, to reach the telescope. Now, 18 billion light years, you have to understand that because the universe is expanding, uh, the light source itself that they're using is also being moved by the expansion of the universe. So that's what allows them to get light that's traveled 18 billion light years. The universe itself is no more than, I think, 13.7 billion years old. So how could a beam of light be 18 billion years old? Well, it's not 18 billion years old. It traveled 18 billion light years. And that's due to the cumulative effect of not only the light traveling, but also the universe expanding at the same time. So it has the effect that the light has actually traveled 18 billion light years. But 18 billion light years is an enormous distance. It's enormous. The entire supposed diameter of the known visible universe is only 42 billion light years. So this is almost half the distance of the entire visible universe that this light has traveled. So it's traveled an incredible distance. So over that incredible distance, if there was quantum foam or this frothiness at these Planck levels, it should show up in a disbursement of the energy of the light coming from that source. So the idea is if photons take discrete steps through space-time and accumulate Planck scale uncertainties at each step, then the espresso observations require that the step size must be at least greater than 10 to the 13.2 Planck lengths. That was their conclusion. So the idea is that if there's this quantum frothiness, then there's steps through which the light travels. This bumpiness, each bump is basically a step. And their conclusion was, well, we didn't find this quantum fluctuations, this quantum foam. We found that it was smooth at the Planck level. There was no disbursement of the energy level of the light that had traveled 18 billion light years. And their conclusion was, well, if there is something going on at that level, it has to be a level that is at least the size of the Planck length times 10 to the 13.2. So essentially what you're talking about is that the study is saying there's nothing going on for any size smaller than 10 to the negative 22 meters. So it's smooth. The study couldn't tell you anything about sizes of this size or greater. It was designed to tell you about smaller sizes than that. If the sizes were bigger like this, then there wouldn't be as many steps over an 18 billion light year distance, and therefore the effect, the disbursement of energy, wouldn't have been measurable. it would take you'd have to have the light travel a much longer distance than 18 billion light years to rule out distances bigger than this. So because the study only dealt with 18 billion light years of distance, it wasn't able to say anything about distances greater than that. But it was able to say something about distances smaller than that. And what it said was, there's nothing going on smaller than this. There's no fluctuations. There's nothing going on. Now, this is a big deal. This is a very big deal. What they're saying is that infinite subdivision doesn't exist. It's not real. You cannot infinitely subdivide things. At sizes less than this, it's smooth. There's nothing going on. There's nothing to subdivide. How can you subdivide something that's not there? It's smooth at that level, meaning there's nothing going on. You can't subdivide something that's not there. So this science is proving that infinite subdivision is false. It's false. Uh, this is a very interesting study. So, for instance, the size of protons and neutrons are about 10 to the negative 15 meters. The size of quarks. Quarks are the smallest unit of matter that has been proven to exist scientifically. Protons, neutrons, they're made of quarks. And quarks are 10 to the negative 18 meters in size. There's a hypothetical particle called a preon, which is hypothetically what quarks are made of. And the size of the preon is 10 to the negative 21 meters. Now, again, preon's never been proven to exist. But if it did, that's how big it would be. Notice that this study shows that anything that is smaller than 10 to the negative 22 doesn't exist. It's not there. So what we have is we have what one might expect if there was a discrete unit of reality which can't get any smaller. So what you have is the smallest known unit of matter, which is 10 to the negative 18, which is only 10,000 times bigger than the smallest thing the study could allow. So a quark is 10,000 times bigger. A preon, if it existed, since it's 10 to the negative 21, is 10 times bigger than the limit of the study. So somewhere between the quark and the study is the smallest indivisible unit of reality. So it's somewhere between the size of a quark and 10,000 times smaller than the size of the quark. But that's exactly what you would expect, because you would expect the smallest unit of reality to be fairly close to the smallest known unit of matter, which is the quark. So if the quark is made of this smallest unit of reality, you would expect it in terms of relative size to be fairly close. And something that is at most 10,000 times smaller than a quark, that's fairly close to the quark itself, which is the smallest unit of matter that we are aware of. So this study is very consistent with what we know about known physical matter. And the study is essentially implying that there is a smallest indivisible unit of reality somewhere between the size of a quark and 10,000 times smaller than a quark. So that smallest indivisible unit of reality exists, it's real, can't be smaller than 10 to the negative 22, and it's somewhere here in between these in this scale. Uh, that's a stunning scientific proof that infinite subdivision is impossible. It is not real. It doesn't exist in reality. And that's a big deal, a very big deal. So, from the scientific study, we can know that, scientifically speaking, infinite divisibility is not real. That reality is discrete, it is not continuous. Things are not infinitely subdividable. Things cannot just continue to get smaller and smaller and smaller and smaller forever. That is false. Um, so, again, there's no such thing as an actual infinite in physical reality. Atheists love to rely on this idea of infinity in physical reality, but no one has ever scientifically proven that it exists. And here's scientific proof that it certainly doesn't exist in terms of dividing things as small as you possibly can forever. So, an actual infinite does not exist in terms of division into smaller and smaller parts. It comes to a discrete, indivisible unit of reality. And the importance of this is, if there's a discrete, indivisible unit of reality, and there is, the study proves it, uh, that means something has to create its order, its arrangement. There has to be a beginning of time and space time because of this. And that means there has to be um, an uncaused metaphysical cause of this space time. And we call that God. So this study is a big win for God. Big win over the atheists. Huge. Important to know about this study. Actual infinities are not real. You cannot infinitely subdivide ad infinitum. You can't. It's been proven scientifically. You can't do that. All right. So if somebody tries to tell you things can be infinitely subdividable or there's actual infinities in material reality, they're wrong. And you can cite this study and tell them you're wrong. There has to be a God to do all this. So I thought, that's a great study, and you really should know about it. I'll put a site to it in the comments below. If you have any questions, please leave them below, and I'll address them. And please press the subscribe button. I appreciate it. And remember this study. This is a great thing for theists. It's a great study. All right. Take care, everybody.